This normal maths modulus question is crazy for 10 marks. Let's have a go, Mai. Find a set of values of x that satisfy that. Now, usually in normal maths, we have a modulus around like a linear function, maybe a quadratic if they're feeling a bit nasty. We've never seen a question with a recip function. So how do we do it? We should always be thinking about sketching the graph. So basically, this is a lesson for you guys on how to sketch recip graphs. Now, I'm not going to do too much on the negative side because modulus obviously means to reflect everything underneath upwards. But how do we sketch these recip graphs super quickly? Well, the first thing is we should be trying to find the asymptotes. Asymptotes are where the functions are undefined, all right? Now, in any division, the undefined numbers are when you divide by 0. So you're basically saying, look, I can't divide by 0. So we make it equal to 0 to find the x value, which we're not allowed to substitute. Now, when you make that equal 0, you get minus 2. So we're going to do a dotted line vertically at x is minus 2. All right. The next thing we need to do is we need to find the y-asymptote. Now, we all know that recip graphs go off to infinity and they tend towards the asymptote. Okay. So what we do is we consider when x tends to infinity. Yeah, now there's different ways you guys can think about this. One way is in your calculator, you store the value of like 1,000,000 and you do 4 times 1,000,000 over 1,000,000 plus 2. The answer is going to give you 4. Why? If x is super large, some of the values here become insignificant as part of the number. So if you have 4,000,000 divided by 1,000,000 plus 2, that plus 2 adds such small of a difference to that million, it might as well have just not been there. Okay? You could think of it as, imagine you won £1,000,000 in the lottery. If someone asked you for £2, it would mean nothing to you. Okay? Or if someone owed you £2, it really doesn't change your net worth. Okay? So, economics and that. So, this disappears as you consider x tending to infinity, and we're left with 4x over x, which is 4. And that is the y-asymptote. Okay, y is 4. And that's significant because it's going to be this 4 minus x crosses the y-axis at 4. Okay. Now, the next thing we need to do, so what students think is that it must be like this. Okay, but we don't know that yet. We first need to work out where it crosses the x and y-axis. And we can do that by just substituting x is 0. Now, when you make x equals 0, the whole thing becomes 0. So it crosses here. All right. So it's not like your standard positive recip graph. If it's going to be in the negative, if it's going to go through here and be between these two asymptotes, it's going to have to look like this. Okay. So it's this and this. Yes. Students think positive, positive. It must be a positive recip graph. That's not the case. All right. Okay, cool. So let's do our little sketch. Now, I'm going to do a little bit of editing here. So we got this and we've got this. All right. Now this is this graph without the modulus around it. With that modulus, anything underneath is going to reflect upwards. Okay, so here it's tending down towards the negative side of the asymptote. After reflection, it's going to reflect back up towards the positive side. So actually, it is going to do something like this. Okay, so that is my recip graph with a modulus sign around it sketched. Nice. Next thing, we just sketch this, 4 minus x. Now 4 minus x is going to, perhaps I can do it in a different color for you guys. That is going to cross, I'll just use this one. So y is 4, it's going to cross here. And it's going to have a negative gradient. Now with respect to the recip graph, it doesn't really matter how steep you make it. Okay, obviously just don't make it vertical. It's going to look something like this. Okay, so this is y equals 4 minus x. And then you have your recip graph, all right? Now we want to find when the recip graph is larger or equal to 4 minus x. So the first thing we're going to do is we're going to find out when they're equal to each other, which is here, here, as we go along, and here. There's 3 places. We need to find all 3 points here. All right. Now we need to label some sections. The section that was not reflected, this has the OG formula, okay, which is 4x over x plus 2. So that's this line and this one, 4x over x plus 2. This is the reflected version. We multiply the whole function by minus 1. So this is the negative of this, which is minus 4x over x plus 2. And what we're going to have to do, we are going to have to solve both this and this with this. All right? So let's do the one that's going to generate 2 solutions first. So we're going to have the first one, which is 4x over x plus 2 is 4 minus x. We're going to multiply through by the denominator. So we get 4x is 4 minus x times x plus 2. Let's expand. So we have 4x is another 4x plus 8 minus x squared minus 2x. The 4x's cancel on both sides. Bring all that to the other side. So we get x squared plus 2x minus 8 is 0. Are we to solve that? That does factorize actually. I was going to complete the square. So we have x and x, 4 and 2, plus 4 minus 2 to make plus 2. So x is minus 4, x is 2. Nice. So that's 2. And this is minus 4. It looks realistic. It's less than that x is minus 2. Now let's do the same thing with the negative one. So we have minus 4x over x plus 2 is 4 minus x, multiplying through. That times that I've already expanded already, so we get what? 4x plus 8 minus x squared minus 2x. Unfortunately, things don't cancel. So we have x squared, 2x, subtract would be minus 6x, and then minus 8 is 0. Now, does that factorize? No, because if you use 4 and 2, they would both have to be negative to make minus 6, but that's not plus 8. So I'm going to have to complete the square here. You could use the quadratic formula. X minus half that value, 3, squared, minus this number squared is minus 9. Then minus 8 is 0. We get x minus 3 squared is 17. So when we square root, we're going to get plus or minus the root of all that. So x is 3 plus or minus root 17. Now, which one do we want? It's obviously going to be the minus one, right? Because 3 plus root 17 is clearly going to be positive. Now, root 17, you can think of it as it's bigger than root 16. Root 16 is 4. This is bigger than 4. So when you do 3 minus that, it's obviously negative, which is this solution here. So 3 minus root 17. Cool. Now we can focus on our solution. When is you can think of it as the black graph bigger than or equal to my red graph? All right. So you always go to where they cross over, then you go to the left and the right, and you see which one is on top. If I go to the left, red is on top of black. I don't want red to be on top of black. So it is on this side, the right side, and it's between these two, okay? We keep going this way up until this point, yeah, this point here where they're equal. If you go slightly to the left, you can see black is above red, all right? Now, we have to be very careful because what do you notice? There is a break in between, okay? So what I'm going to do is I'm going to say that my first solution is bigger than minus 4, yeah, so I want this side, but less than minus 2, okay? So my first solution is x is bigger than or equal to minus 4, yeah, because it can equal, yeah, so it can equal, but strictly less than minus 2, all right? Then I have this mini solution in between the minus 2 and the 3 minus root 3 minus root 17. So I have the minus 2. It cannot equal that, x, but then it can equal the 3 minus root 17. Okay? So there's that solution which I've done separately. Now here, when you go to the right, you can see red is above black. Red is above black all the way over here, all the way until we get to this point 2. Where when we go to the right of it, you can see the black is above the red, which is what we want. So my other solution there is that x is bigger than or equal to 2. And there we go, guys. There are 3 solutions to this problem. And that's quite a difficult problem. I mean, the maths here is not difficult, but you guys can see it's all in the graph. Now, some students like to say, oh, you square both sides. You will not factor in that minus 2, I can guarantee. And writing this solution will be way more difficult for you. So it's all in the graph. Guys, if you learned something today, hit the like button. And for more content like this, hit the subscribe. You can head to my Lungang Reddit page to submit questions and discuss more things maths. And if you're interested in my A-level maths courses, we are going through papers now. Links in the description. See you guys in the next video. Nice.